Okay. Thank you, Curtis, so much. I really appreciate it. Curtis, yeah, everyone's excited to see you.
Hmm.
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 Wow. I'm excited to be invited back. Um, I assume that every time that we do these, that there's someone new and maybe doesn't know who I am or our lab. So I'm Dr. Curtis Coughlin. I've been studying paradoxine-dependent epilepsy since 2010, and just really, I'm at the University of Colorado. Just really excited to be part of the community. I am definitely coming to the family meeting in Colorado, but that's selfish as it's going to be right next to me.
Hmm.
um, and so I hope to meet many, many of you if I haven't already. And so I'm going to give a talk today. If you've never seen me talk before, I try to be casual. I would be more than happy if someone wants to interrupt me or ask questions or have a conversation. I don't even really like using PowerPoint slides, and maybe you'll notice about how bad my PowerPoint slides are that you'll feel like, yeah, he really doesn't like it. So more than happy to talk about other things. So I'm going to share my slides now. And our very exciting topic is metabolic dysfunction. And I guess I have a couple of goals here. One, I want to share the work that we were so generously funded by Cure PDE to do this year. And we're really excited that we have the opportunity to answer some scientific questions we've been wanting to answer. As you may know, that in science, we don't really have the ability to just do whatever we want. We really have to be able to figure out how to pay for every part of it, from the people's salary in my lab to the experiments we do. And that's been increasingly more difficult with the lack of federal funding. So we're really excited we have this opportunity. But I want to talk about, why do we care about metabolic dysfunction in PDE? Isn't this a seizure disorder? And does it actually mean anything for me or my child? So I hope to make it a little bit more personal. So we all think about this disorder because of seizures. And maybe that's why you're here, that you or your child first had a seizure and someone thought about paradoxine dependent epilepsy. And maybe you know, and this is a nice video from from one of our families here, that seizures can look very different. About 70%, so about 2 out of every 3 patients, have seizures in the first month of life, but not always. Some kids have seizures in the first few months of life, in the first year. I know a family where the patient had their first seizure after they were 18 years of age. And so it can really happen at any time, not just in the newborn period. And maybe you also know that the reason we treat with B6 was almost a happy accident or a mistake that happened in the 1950s. So in the 1950s, there was a group in Philadelphia who were trying to understand why premature babies did so poorly after they were born. And they were giving them a shot, a mixture of a whole bunch of vitamins to see if they could help those children live longer. And it just so happened that one of those kids had seizures. And when they gave them all of these vitamins, the seizure stopped immediately, which was not something they were expecting. And so they did what any scientist would do, and they started giving just one vitamin at a time, and really showed that this child needed vitamin B6 every day to have their seizure stopped. And for 50 years, we just tried vitamin B6 in kids, not really knowing why it helped their seizures. We still to this day know that everyone, we believe, should be on vitamin B6, but we don't actually know how much you should be on or your child should be on. We give really general guidelines based on how much you weigh and how old you are. So we give more to children, mainly newborns, because they have a difficult time holding on to or synthesizing B6 in their gut. So they just need a little bit more. And as our kids get older, they actually make a little bit of B6. and they get it from some of the foods they eat. So B6 is in almost everything, but it's in vegetables, it's in meats. I know that most of us are watching the meats that we're eating. And so we give a little bit less to children. And then when you're adult, we give you even less. And again, these are really general recommendations. And I have a lot of families that call and say, thanks for the general recommendation, but what about my kid? And that's something that our research lab is really trying to work towards. How can we figure out how much you need? All right. Seizures, we give B6 to everyone. So why are we talking about metabolism at all? And I did my PhD training in metabolism, so that's what I'm really interested in. Well, the group in the UK, and maybe some of you have seen me show these slides before, in 2006, so not that long ago, 2006, a little about 20 years, actually showed that PDE is due to a genetic disorder, a genetic cause of one gene called ALDH7A1. I know it just rolls right off the tongue, ALDH7A1. And so you may see some of the papers we publish. We actually call this disease paradoxine dependent epilepsy dash ALDH7A1. And the reason we call that in our papers is that's the gene that's involved. So many of you on this call or your children have genetic disorder caused by this gene. Some people on this call have a B6 disorder caused by a different gene. And that's not what I'm talking about today. I'm talking about this one gene, ALDH7A1. So, what happens in this genetic disorder is that there is a block in the way that we break down lysine. Lysine itself is not bad for you or your kid. Lysine itself doesn't cause any problems. The problems is that lysine can't get broken down. And so what happens is it gets stuck and it starts to make these other metabolic metabolites very high that are supposed to be not even present. These things lysine should be broken down so fast that when I take your child's blood, I should not be able to see almost any of this AASA. But because of this genetic defect, you have a lot of it. And what happens is that this chemical that's not supposed to be there interacts with B6. So this is a little cartoon I use, and it may or may not help anyone. So the B6 is this little green Pac-Man, and it runs into this chemical that's not supposed to be there. It's called P6C, and they interact with each other. They bump into each other. There's a chemical reaction, and they create this very brand new purple chemical that the body has never seen before, and it can't use. And you basically pee it out. So what that actually means is that all of the B6 that is in your body starts to bump into this thing that's not supposed to be there and gets turned into something that can't be used. So for the first time, we actually realized why we need to give kids B6 because all their B6 is kind of gone. And this genetic disorder made sense why, all right, it was a happy accident that kids' seizures were responding to B6. We didn't know why. And now we know why. It's due to this metabolic cause. It made us as scientists feel really good that, why we were doing it. So that was 2006. And there were a couple of papers published about kids with PDE. And I want to say that this is general data. This is stuff that we are publishing on average. So if this doesn't feel like you or your kid, that's very possible. So I'm just talking about the average kid with PDE. So in 2008, Dr. Sid Gosby, who might be on the phone call on this at the moment, his group surveyed families from around the world, mainly in the US, and asked parents to describe how their kids were doing. And the parents said that about 80% or 27 out of 34 kids needed special education at school or were not at grade level and required some combination of physical, occupational, or speech therapy. So most kids weren't doing grade level work at school, and needing some help. Again, might not be your kid. This was just the majority of children. And so we did some formal IQ testing, and I'm going to show what IQ testing is in a moment. But it's a formal test that's done, and it takes hours if your kid's ever done these developmental tests. And it tried to compare how kids with PDE were to kids who weren't with PDE, and showed that the average IQ in this small study in the Netherlands was 72. And in a larger study that I published about 2 years ago, the average IQ was 75. So what does that mean, the average? So this is the general population in the world. And on average, the person, just a general person who has no health problems, their IQ is 100. And the higher the IQ, sort of the better they're doing on that test. Some people will say that they're smarter, but it really is just saying that they're good at taking this test. And the lower, it's the worse they're doing on that test. And this red bar has been over about 10 studies where the average kid with PDE is. So you can see it's on the low end of sort of developmental test scores or how kids are doing in school. So we had a bunch of these data about 20 years ago. And our thought was, well, we have to do better. We have to find some treatment that makes kids do better than this. We're really good at controlling the seizures, but we want to see this red line move right into the middle so that a kid with PDE does the same at school as any other child. And we went back to this idea of metabolism. And we know where the genetic cause is, this big red X. And we know and we believe that this chemical right here, alpha aminoadipic semialdehyde, or I'm going to call it AASA, is bad for your brain. And so I'm going to spend the whole talk talking about the fact that we think AASA is bad for your brain and what we've done over 15 years to make this lower, and whether we have evidence that it works, and what we're going to do next. So we're going to talk about metabolism. So at this point, does anybody have any big questions about what we're going to talk about? I see Jen shaking her head no. I really appreciate that. Okay. So this is what we think is happening, is that we think that this chemical, and I drew out some structures because I use this is what those chemicals look like. And I use this picture when I'm teaching other scientists or doctors too, is that we think this chemical coats your brain over time, and it actually does lead to the seizures and to some of the difficulties in school. And we also think that it leads to some small changes on your child's MRI. So if any of you have talked to your doctor about really small differences on MRI images or have talked to us, we think that it's all due to this chemical that's floating around in the body. And so in 2010, we started a research study where we would give kids this formula that that had no lysine in it. So it was all of the other amino acids, um, but lysine. And so by giving kids less lysine, the hope was they would make less of the thing that is bad, AASA. And I know at least one of you on the call was in this study. Thank you very much. And so here's just one patient. I purposely picked someone who would not be on this call to show their data. But this is one patient in our study. And this blue line is their AASA level over time in the research study. And this dotted blue line is the normal level that we see in kids who don't have PDE. And so we knew that it was pretty high. It was 20 times the level of normal. And when we started this patient on a lysine restricted diet using this formula, you can see that right away it dropped really low and it bounced around a little bit. And we're going to talk about why that is. By the end of the study, it was really close to normal. So this was the first evidence we've ever had, and we published this in 2012, that by changing how much lysine a child was eating, we could lower the AASA level. And then some of you were also in this next study that I led. So this one was led by Dr. Clara Van Karnebeek. I was a part of it, but I wasn't in charge. And I got to lead this second study.
Let's
And
edit that. We
yeah,
can
does someone
edit
have a
button on your
question?
dashboard thing there. The link template list.
I wonder if someone has a question or just unmuted.
Like
So if I
everything's
miss,
moving slow right now for some reason.
thank you, host. um, So we started a second study actually in 2012, right at the end of that other one, where we added arginine to the therapy. So I'm going to explain why I added arginine, and Christy in my lab is here, and you won't be able to see how upset she is about how I explain this, but it's the way that it works for my mind. So lysine gets into this pathway to get broken down through this tunnel, this transporter, the same way two other amino acids do. They're called arginine and ornithine. And so the way I think about it is I don't know if all of you live near a major city, but I live in Denver. She's already upset about this. um, and I don't know if you've ever tried to drive on a highway in the middle of the night, but it's so beautiful, right? There's no cars. You can drive as fast as you want. You can change lanes, and there's nothing stopping you from getting to your destination. And actually, lysine is the major amino acid that goes through this tunnel. And usually it's flowing as fast as it wants through and getting broken down. And so what we try to do is sort of stop lysine from getting into this pathway, into this tunnel to get broken down by adding a lot of arginine. So now imagine you're on that same highway at the height of rush hour. So, you're driving at 2 in the morning, you're flying down the road, driving as fast as you want to, or the speed limit. But at rush hour, you're usually in bumper to bumper traffic. You can barely, you're driving 5 miles an hour, you can barely get anywhere. And sometimes people just turn around and go home. And that's the idea of using the arginine is we're creating um, this traffic situation so that lysine can't get into the mitochondria, it can't get broken down, and it cannot make the AASA. Again, lysine isn't bad for you. It is the AASA that is bad for you. So that was our idea. And every time a scientist says, here's our idea, you should ask right away, does this work? All right, here's some questions that I am not answering. I will say what you taught me. Arginine confuses the transport of the brain to let lysine in. Thanks, Jen. I appreciate that stuck with you. Um, and so does this work? Does giving arginine help? Well, this was our second study that we published. And so here are again average levels. The most important one's the first one, the AASA. And so the yellow bar was kids that were just taking B6. The pink bar is when we put them from B6 onto the formula. And you can see that ASA went down a lot. And then the blue bar is when we added arginine. And you can see in all of the things we were measuring, they all went down. Again, this is the average kid. I don't know that this is helpful for you or your child. I'm really talking about average. And so it made these ASA levels lower. Jen might have also heard me say this, although I don't always say it out loud. But there was a big part of me that was worried all I was doing was making this chemical lower, and I wasn't really helping kids. Like it looked good on paper, like I was able to publish papers, and it made me feel good as a scientist in a lab. But were we really making a difference? And so actually, I'm the most proud of anything in my career is probably this paper that we published in 2022, where we compared kids who were taking just B6 to kids who were taking B6 plus any of these lysine reduction therapies. So that means if you were on formula, if you were on a low protein diet, if you were taking arginine, we sort of put all of the kids into this bucket. And so there's a lot of things I'd be happy to talk about this paper for, but the thing that was most exciting was that kids who were taking the B6 and the lysine formula, their IQs were better, especially when they were in the first 6 months of life. So this was a 22-point improvement. So let's look at that. I think this is easier to see what that means. So kids, the average kids here in this red bar, and the purple bar is the kids who were diagnosed early, taking B6, and also taking one of those lysine reduction form therapies. So again, the goal is to be right in the middle, right? I want to see no difference between kids with PDE and kids without PDE. That is our goal. That is why we keep working on new treatments. But you can see we're a lot closer. In fact, this IQ is, I don't love this terminology, but it's considered in the normal range. So it is like that you would not qualify for any services with this IQ level. Again, I'd like it to be exactly even with kids without PDE, but it was really important for us to show over time that these treatments lowered AASA levels. That's really good. The labs got better, but also the kids got better. So it suggests that we were doing something. And at this moment, I hope everybody's doctor has seen this guidelines that we wrote. We think that every person should be on B6 and that most kids, not everybody, should consider trying some way to reduce their AASA level, whether that is through a formula, through watching the protein that they eat, from taking arginine or some other form. And if you're already not tired of my voice, we did a podcast about this with myself. And actually, this is Dr. Peter Clayton, who identified the genetic cause of PDE in 2006. And this is Dr. Emma Foote, who is the main doctor in the UK who follows kids with PDE. And so if you want to at least listen to the other two, they have really beautiful accents. And we just talk about why we think that all kids should be treated this way. Okay. All right. That was a lot of metabolism, a lot of discussion of AASA. Does anybody have any questions before we talk about like what we're going to do next? I'm going to stop sharing for a moment so we can see each other.
So Curtis, one of the things that I wanted to just highlight, because what I'm noticing, again, I'm a little more seasoned in the PDE parent situation, but one of the things that I think that super helped me as a parent of a child with PDE was that what you talked about earlier, the IQ thing, right? It's a measurable situation. But when Emma's numbers were all over the place, you would always ask me, are you noticing any differences? Like you would always say, I don't know your child as well as you know them. So I can't say if numbers are good or bad or whatever. I can just say what's quote unquote normal, what we're shooting for kind of thing. And I think as the parent, we get in this trap of comparing our children, whether they're stereotypically normal or not. But our kids could have challenges, and I'm just as bad. I've had all the conversations with teachers, all the things, right? But the way that you guys kind of set me up to deal with our life definitely helped to not get me so wrapped around and being scared of the numbers, because her AASA, if you can, and for what it's worth, sir, you can show her numbers anytime you want, because they are all over the place. So you can show that there's no consistency in her numbers. A growth spurt, they would spike or they would go down. There's all the things. So, but I just wanted to highlight, because we're in these groups and these chats and we talk a lot about like tying everything to PDE, when sometimes it could just be how our kid is or what makes them them. It's not always a PDE thing. And then also don't get tied around the numbers.
Yeah, Jen, so perfect. I'm gonna show not yours because I feel like I pick on you guys a lot. So some other patients in our research study, their ASA levels and how all over the place they are, and why I don't know if everybody understands why your numbers could jump. So I'm gonna talk a little bit about that, and actually why this research study we're trying to figure out a way to control for all of the things that could make your numbers look all over the place. I really hate using IQ as the thing we talk about because it's just a test. It's just a number. I will say it's easy to get things published in journals because every doctor knows what an IQ is. But when I'm actually seeing patients, I really do want to know the everyday things that either are better or worse. Yep, I'm glad that people remember things I've said. So thanks, Becky. Um, it's not just about PDE. Like our kids are our kids, and they're all very different from each other. And as a scientist, it gets really hard for me too to figure out what is PDE and what's not. But I want to remind ours that our kids are our kids, and that IQ is just really one very specific test and not really who we are. There's a mom who is not on this call. I can see she's not. And she used to tell me about all the amazing things her daughter was doing as we sort of made her B6 levels good and we lowered her ASA as much as possible. And her IQ didn't change. And she would just tell me all the time, like, Curtis, she's doing this and this and this. And it's so much different than it was last month or last year. And we see all these amazing things, and constantly reminded me it's not just not about one test. It's just that that's the test number that we tend to publish. And also, I am always talking about the average kid, and you and your kids are all different, which is again part of our research studies over the next years, we hope, is we really want to figure out, can we figure out what's best for your child, for you, as opposed to on average. Any other questions about like why are we focusing so much on metabolism? Why do we talk about the AASA so much?
So when you talk about the metabolism, is it initially there was a study I thought you were going to do because we don't know how long B6 stays in the metabolizes before it's not there, right? Because like we take B6 3 times a day. Some people take it once, some people take it twice. So is that part of the study to determine that, to kind of standardize some more of that?
Yeah, Christy's working hard right now. Again, she's right here in the lab because we say B6 and we say paradoxine as though they're the same thing. But paradoxine is one of 6 different forms of B6. And so what we really need to do is to think about how all 6 of those forms of B6 are present in your child, like where they're getting their B6 from, how they use it. So one thing we will be doing in this study is trying to understand how long the B6 is present when you give an animal model B6, how much the ASA level impacts the B6. But our goal is to move this stuff to humans. And one thing we talked about Jen's family doing, and we never did do it, is to like have someone take to put a line into their child to put, to put one of those, we call it a PICC line or a catheter line, so we can have blood draw whenever we want, and to be able to take blood samples throughout the day. So we can see where your B6 level is before you take your B6, and then an hour after, and then 2 hours after, so that we can start to figure out how often you need and how much B6 you need, because the amount that varies over patients is so wide. Some patients need just a little bit once a day, and some patients need a lot every few hours, and we haven't been able to figure out how to tell that difference. But that is one of our goals. Try to figure out what it means for you. And so we give these general recommendations in that paper and in that podcast. But, it works for some people. Some people need a lot more. Some people need less, and we just never know it because your child's not seizing. Your child's doing fine. So you don't think about reducing the B6. All right, so I either bored everyone or answered everyone's question, it seems like. We can do more. I told you I wasn't great at PowerPoint slides. We can show some more. Anastasia, are you reaching for the mute button because you have a question?
Yeah. Oh, no, I do have questions, but I'm gonna hold my questions until the end because I know you have another topic to talk about. So
Yeah, so let's think about what we're going to do next, or sort of where we are next. I don't know that that worked the way I wanted. Let's try that again. All right, now are you guys seeing my slides move? Okay. So really, this is one of our big goals, right? Like, we know that all of these kids have PDE, but every kid is so different. And they're different because of your family. They're different because of other illnesses they might have. They're different because almost all of you have different genetic variants. I know most of your genetic variants. We published a paper in 2019 and showed 180 different types of genetic mutations, all different ones. And so they all have a different impact. And I also do know some patients that I think only ever need B6. They're adults in their 40s. They're doing great on B6. I actually probably wouldn't give them any other treatment. I know a lot of kids that I think really need B6 plus some of our lysine therapies, whether that's the diet or arginine or both. And there's some kids who need something more than that. But it's really hard to tease it apart. And that's my goal as a scientist, but also your goal as a family. I would love for someone to get a newborn screen diagnosis of PDE and us to be able to say, all right, you have PDE, and this is exactly what your child needs. We know all the information, all the variables, and this is the best for your child. And that is our goal. And right now, that doesn't happen. When your doctor calls me or you call me, I say, on average, a patient needs this. And that's not what you want. You want to know about your kid. So that's part of our goal. We know a few things that impact outcomes. And so I know this is a busy slide with a lot of numbers, but this is from that same paper I'm so proud of. And so how to read this chart on the left? Well, we know some things impact how well your child does. So let's look at this blue box called delay of paradoxine in days. So how we read this estimate is that on average, a child loses this many IQ points. Remember, this paper was just on IQ every day that they are not getting the paradoxine. And so for many of you, your child was treated the first day they seized, or your child was treated 2 days after they seized, or a week after they seized. And yeah, that week had some negative effect. Very, very small, really small. But I also know some people who want 10 years without paradoxine, and this had a really big effect. Some other things that we know, the later your seizures start, you get sort of a benefit in the outcome, and we think that makes sense. That's probably like your metabolism is more mild. Yes, Kara, your hand is up. I love that.
Sorry, I couldn't figure out how to unmute. So you say that the study shows that every day that they don't receive B6, that their IQ points can lower a certain amount. Is that, I know B6 can build up in your system over time. Is that multiple, like based off of them starting out with nothing? Or is that if we were to like miss a day for whatever reason because of sickness or something, would that
Really, it
also
was
happen?
the your child or you are seizing, and you are getting less than good seizure protection. So maybe some of you tried other anti-seizure medications and they sort of work. That's usually what we hear. Like we'll try, like the most common medication tried in children is usually Depakote or valproic acid, and they tried it and then the next thing, the second most common medication we try is Keppra, and they tried it and they kept trying medications. And so the number of days that your seizures aren't as well controlled.
Okay, gotcha.
Yeah, there are times that kids miss a dose of B6. I usually tell this story of a teenager in our research study who was diagnosed at 8 days of life and didn't remember having seizures, which is amazing. and didn't believe me or her mom that she needed B6, right? She never had a seizure. She feels like everybody else. She's taking this vitamin. She doesn't believe it. And when she was a teenager, she stopped. And it actually took 2 days before she had her first seizure, like 2 days of no B6. She just, um, when her mom gave her B6 pills, she just threw them right in the garbage. I think she was actually hiding them in her room. I can't remember which one. Um, but that happens. This data is actually more of the newborn, like how long before someone knew you had PDE.
Right. Okay. That makes sense.
We also saw that premature birth could have an impact on that. Actually, the more premature you were, and that's consistent with other things, like the more premature you are, some of the more difficulties you have. So some of this wasn't that surprising to us. You'll see that I don't have AASA levels in here. And as Jen said, part of the reason is that they can really vary a lot. So here are 2 subjects in our research study. Neither are on this call. And we've gotten 25, actually, I think we've gotten 50 plus AAS levels over time. And I got lazy last night and I only entered their last 25 values. Subject number 1 actually is at grade level in school. She's doing pretty well. Subject number 2 is nowhere near grade level at school. She is really, really struggling with sort of general school and daily life skills. So these are 2 very different children. You can see that subject number 1 on average, so this box is this big black line is showing the average values of her study, and you can see it's lower than the kid who's not doing well. And that makes us feel good that this AASS level is helpful. But let's pretend for a moment that I only got 2 levels from these kids. And many of you don't get very many AASS levels, or those of you in our research study, we don't get a lot of them. And so if I just happen to get these 2 levels, it'd be really hard to tell these 2 kids apart, right? Just 2 moments in time, and they're not overly helpful. And so that's very frustrating to us to try to figure out what to do with this data. And your AASA levels can really be very different. And here's just some of the reasons why. Yes, your genetics make it different. So I said there's over 200 different mutations. We published that 180 of them. And so I have some guess as to where your AASA level is if you tell me your mutation, just some guess. So that does impact it. So does definitely how old you are when your children are really growing very fast. Like let's think about your kids are doubling in size when they're infants. The AASA level is actually pretty low. And that's because all of the protein you're eating is being incorporated into muscle. All of that lysine is going into muscle. So there's not extra lysine that needs to be broken down. It's just being incorporated. So when you're an infant, it's going to be low. As you get older, it's going to go up because you're just not growing as much. Or maybe you're growing in the wrong way. You're not growing in the place where you're adding muscle and height. Obviously, so those 2 I can know. Like I can know how old your child is. I know what their probably growth rate is. Like on average, every 6-month-old is kind of growing at the same rate. These are the parts we don't know. So we don't always know your diet. I'm guessing many of you have seen a metabolic dietitian, and they probably ask you in clinic, like, tell me about the last 3 days of what you or your child ate, and you're supposed to like guess how many cups. And I'm always amazed that you're even able to do that. Or maybe they have you fill out. Jen's like, yeah, I'm trying. Maybe they're asking you to write it down in a diet record. And so we try to get some idea of how much you ate. But these things also really impact it. How active your kid is. Like if they were running around all morning, they were at gym class, or they were playing soccer, that really impacts your AASA level. And I usually don't know that. How long it was since the last time you ate lysine really changes it. The longer you go without food, the more that your muscle starts to get broken down. This is just every human in the world. This is what we do. Like if we don't eat, our muscles get broken down so that we can have energy sources. And there is a lot of lysine that floods the system. So if you ate 2 hours before a blood draw, your level's going to be pretty low. If you ate 15 hours before a blood draw, your level's going to be higher. And then another really big one is how sick you are. The sicker you are, you also break down that muscle and your AASA level goes really high. And I usually don't know these other three things when I'm looking at your lab. Yes, Kara, another question, please.
Would you say it's better than for kids who have PDE to like snack more frequently to keep those levels lower?
Yeah, what we hope most clinics are doing is only worrying about the illness part, because you end up with both things. At least my kids, maybe your kids are different, but my kids are sick. They also tend not to want to eat anything. And I end up trying to bribe them to eat things like, how about some ice cream? How about some Gatorade? How about some sugar pops? But usually both of these things are happening. You're just not eating what you need to, and you're sick. And that's really what is flooding the system with lysine. And so I'm hoping that most doctors are making some recommendations about like when you're sick, these are the ways to try to get calories in. I know when Jen was in our clinic, I'm sure we talked a lot about getting sugar into the body when Emma was sick. The fasting part, I hope that most clinics, at least our clinic does, try to give some guidance when you're getting blood draws on how often how many hours after your last meal should be. But in general, you're right. We don't love long fasting. Your body is breaking down muscle, or what the term we use is catabolism. It's usually after between 12 and 24 hours of fasting. So most kids don't go that long without eating. It's not every 2 hours. So I don't know if that answered your question, Kara, but I hope so.
It does. Thank you.
This is just some of the reasons why your labs bounce all around. I bet Jen was frustrated with me when she was in our clinic because Emma would have a high level and I'd be like, let's just repeat it and not deal with it, because I just thought, well, it's one of these other variables. And what I'm really looking for is things over time. This makes doing stuff in humans hard. And this is why we end up using a lot of model systems in our lab. And we use zebrafish. We just started using some mice, and we use cell culture or bacteria culture, all to figure these things out. Like, what are all the variables? Because we can control the genetics, but we also can control how active the animals are. And we can not only study the whole animal, but things we would never do in children, right? We can take out their brains and look at their brains because that's what we really care about. The downside to using all of these animal models is that animals aren't people. So we do actually hope to move the stuff we do from animals to people. So what's one thing that we're doing? And this slide looks so complicated, I know. But the way that we actually measure AASA is we use what's called a mass spectrometer. And this was the very foundation of all of my PhD research as a doctoral student, and what our lab does and what Christy does every day. And we can decide how much she loves the mass spec based on her face every day. But what this does is it's really good at measuring something in a very complicated sample. So if you think about athletes at the Olympics, you get their blood sample and they're looking for a drug. They're looking for one thing, and all of the proteins and fats in their blood, they can just measure one thing. And we do the same thing. We're looking for just all of the things that are in your blood or in your urine or in a fish. We're just trying to measure the lysine and the AASA and all those things I put on a slide. Well, one thing that we can do that helps us is that we can give the fish or our mice what is called a stable isotope. What that means is we can make an artificial lysine that is heavier than normal lysine. And so that heavier artificial lysine, we can measure, we know exactly how much we gave to the animal, and we can see exactly how much that heavier isotope gets made into AASA or interacts with B6. So we can really say, we gave this amount of lysine and this is what it did. And it takes all of those, like, is the muscle breaking down? Is the fish or mice active? Is our children active? Out of the equation. And now we can just ask questions about that animal, or hopefully someday about your child. And so this is what we're going to do at the moment is we're going to feed these fish that we know have PDE. These, as you guys may have heard our other talks, our fish start to have seizures. They start to have them a few days after they're born. We can stop those fish's seizures with B6. So they're very similar to the disease that our kids have. They have all the same biochemistry, and we can just dissect their brain and their liver and ask really questions about them. And so we're going to feed them this very specific amount of lysine and then measure where it goes. And we're going to be able to measure exactly where this heavy lysine goes throughout not only this part that I show you, but so many other things that I'm not showing you. And one of the things we really like about this is that we do have questions like how much of the lysine that your child is eating actually turns into AASA, because it's not all of it. And so that would actually help us figure out how we could decide how much of the diet is important. Do we need to be more strict on the nutritional lysine that your child eats or less? It is possible that the most of the ASA comes from that times that your children are sick or active or muscle broke down, and the dietary part, the part they eat, is not as important. And we don't really know that because we can't tell the difference without using these artificial heavier lysine isotopes. We want to know what else happens to this. The AASA doesn't stay in your body forever. If it did, it would just keep going up and up and up, right? Like it's not like it's a 1 week and then a 3 and then a 5 and it just goes into infinity. It gets broken down, it gets peed out. If we know what's breaking it down, maybe that could be some way for us to develop a new treatment. And maybe instead of worrying about how much lysine you eat, we can just get all of the ASA out of your body as fast as possible. And then you wouldn't have to worry about how much you eat. We also want to take this and apply it to kids. We really do at some point want to feed or give your kids in an IV this stable isotope lysine and measure what it does. And I've done this before when I was in Philadelphia. It helped prove that a drug for another metabolic disease called NAGS deficiency, which I'm sure everyone on this call goes, yeah, we hear about NAGS deficiency all the time, but it's another metabolic disease. And we proved to the FDA that that medication treated the disease by giving those kids that stable isotope. And so we want to also be able to move this from animal models to children so that we can figure out if drugs work. And that's really important because most of our drug development work, we are looking at, does the drugs lower AASA? So I know that was the whole theme of this talk today was AASA. We should get to know what that term is. We think that that's bad. We've been trying to lower it in children. So here's an exciting paper of ours. Well, I'm just one of many authors. I wanted to highlight there's a whole bunch of people who do this work. And so what we did is we made a mouse with PDE, and that mouse has seizures and has the same biochemistry. And we made a drug that works right below lysine. And what it does is it does not let lysine get broken down at all. It sort of stops it. You actually end up with a lot of lysine, but lysine is not bad. These mice have a whole bunch of lysine that they eventually pee out, but the mice make zero AASA. They just make none. And we measured their liver and their brain. And basically we were able to cure the mice by knocking out this step. And so that's really exciting to us that we were able to both change all of the biochemistry and the mice stop seizing. And many of us, include many people on this paper, as well as our lab, are trying to develop drugs or genetic therapies that would do the same things for kids. And if those drugs were successful, kids and adults could eat all the lysine they wanted. It wouldn't matter what the diet is, and they probably would no longer need to be on a diet, and they might no longer need to take B6. And so This study and the ones that we're going to publish, you're going to see that we mainly look at whether or not we normalize AASA. So I'm really grateful. We are so grateful that some of this work was funded by the Cure PDE Foundation. Again, science is really hard right now. We are struggling to figure out how to fund our research with limited dollars coming from the NIH and the federal government. So we can't even begin to express our gratitude for this and also all of the other families who've donated to us and participated in our research. Like we couldn't do this without you guys. And we hope we're doing things that matter to you guys. And if not, you should tell us you're doing things that don't matter and we want you to do something else. I'm going to move the screen over so Christy can also answer questions if you guys have them.
What you do matters deeply and you should continue.
I mean, right now, our two goals as a lab are really like we've been working on newborn screening and we haven't talked about it as much. As you may have seen from Facebook posts or our lab post, we were excited that we submitted for PDE to be considered for the United States newborn screening. And the committee that decides newborn screening is officially disbanded. It doesn't exist anymore. And it's really unclear what the future of newborn screening is going to look like in the US. That doesn't mean that we're not still trying. It's just unclear what that looks like. Christy and I met with a state representative to try to consider to get Colorado to do some screening. We're working with Wyoming to do some screening. But very exciting news is that the country in Italy is voting on adding PDE to newborn screening in June. So it'll be the first country to take an official vote. And that is really based on the work that we did here and with the support from you guys. So we're really excited that that country is voting. And there's some studies in South America and in Canada going on. So we're just really excited that the newborn screening is happening. But two of our big goals is after there's a newborn screen diagnosis, we really want to try to be able to figure out what treatment that kid or your kid or you needs and sort of to move from average kids to individuals. And so we're doing that by doing a lot of stuff in the lab, and we're going to reach out to some of you to get more information. And then the second thing we're doing is we're working on these new treatments to I want to emphasize that I think the dietary treatment actually helps. Like we have some evidence that it does, but we also recognize that taking B6 every day and being on a diet kind of sucks. And we want to try to find some easier way to do it. So those are the things that we're working on. So Alicia said, when I get blood work, it's fasting. Does this change my levels? Alicia, the best thing that you can do is make it consistent every time. So the thing that is the most hard for us is that sometimes you ate 10 minutes beforehand and sometimes you've been fasting for 3 hours. So by far the best thing you can do is just be consistent. And Jen says Emma fasts no longer than 4 hours. Jen, is that just like that's an Emma thing, or that's what your doctors have always told you?
That's what they've always told us. Even when we were there, we fasted because it was terrible to take a newborn who was hungry to a clinic to get poked.
Yeah.
But we've always within the 4-hour window. And then I always write down when she stopped eating, so that way they can add that into their data stuff.
Yeah, that's by far all of those variables what we don't know contribute to the AASA. The more that we know, the better. 4 hours is a pretty tight window.
It actually
I
works
think
out really well because she can eat breakfast and then we do it before lunch. So we typically can make it work.
What I hope is that you're not waking her up in the middle of the night for 4 hours,
no.
that at night you're not.
Those days are long gone, Curtis. Like when we started the every 8 hours of taking B6, the times of waking her up are long gone.
Yeah, and Jen, unfortunately, I know she tells a lot of stories about her time, and I don't know if it was good or bad, Jen, but Emma was born at a time where we were learning so much about PDE, and so some of the things we were doing we weren't sure were helpful, and some weren't. And I don't know that we would have done everything the same way if Emma was here today. But we do not wake any children up for B6.
Well, hearing everybody else's stories on the food, right? Like I still look at a banana and say that it has 0.5 milligrams of lysine per gram, right? Like it's not a free food for me. Or pears are 0.07. So like in my head, I still count things. Whereas when I talk to the other families, they have a lot more free foods. And I'm like, Emma ate air and applesauce a lot as a baby, right? Like, and she's okay. She's totally healthy. But yeah, I definitely think it's gotten better for the family. So it's
Yeah.
okay to take one for the team.
And I'm guessing that Becky's experience with the same clinic a decade later is different. And it's just because we're learning a lot.
Which is good. You should.
And my guess is that I'm hoping in the future that it's going to be different too. Um, I don't know if we're allowed to also call you grandma, but thank you for saying that our work is good as you put in the AKA grandma. Um, a new 7-year-old boys can be hungry all the time. I think that I don't think that that has anything to do with PDE. I think it just makes it really hard when we're measuring the levels in the lab that I showed you that, that big variability from lab draw to lab draw. It's just really helpful to know, how active, how hungry, what did they eat? Um, you know, I always also think that all of our recommendations, we have to remind ourselves that real life is the most important thing. And so whatever we're suggesting has to fit into real life, right? We can't make suggestions where you're basically kids don't go to school and you watch them all the time. So you have to figure out something that works with your 7-year-old who's hungry and active.
So Curtis, I was going to ask you a question. I know there's some in chat. It's just hard for me to click back and forth. But you mentioned something about like if our kids are more active, it could impact their AASA, which is exciting because I do remember initially when we first started, you were collecting that data, but weren't really sure what to do with it, right? Like kind of with the lumbar punctures as well. But so my question is a selfish question. It's about Emma. Like she's super active, right? Like she's moving this summer into 10 hours of gymnastics plus her normal life. Like, is that something that I should maybe talk to my team here about? Like, with in addition to being a little lady now, like the her eating habits and stuff like that, to see if we need to maybe do a few more blood draws to make sure that we are sustaining her somewhat normal.
Yeah, I mean, in general, the more active you are and the more muscle you're building, both the more protein you're going to need and the lower your AASA level is going to be. So it's good to be active. It really helps your metabolism. It's something you should be, as kids get more and less active, those are the times your dietitian wants to change your diet. Um, I, you know, Bringing up things like menses or your period actually also do change levels a lot. We will see big shifts in our metabolic levels in general when you're having a period, or 2 days beforehand is usually when we start to see the shifts in the labs. I know that's probably something our teenage girls don't want to tell the phlebotomist or our team, but it's helpful in knowing.
You'd be surprised. They don't care anymore. They're not shy about stuff anymore. But
yeah, I have a 14-year-old daughter. It really depends on who she's talking to.
True
Depends on how
statement.
shy she is. Yeah.
Okay.
But all those things are things that can impact the levels. And, what you don't want to do is just get one level one time and think that without any of these variables that impact it and then make big conclusions out of it. And it's one of the things I really like about the stable isotopes, that if we were moved from our animal models to kids, none of that would really matter if we use the stable isotopes. And a lot of companies think that's going to be a really good way to prove that a new drug or treatment works. Kara, I think I've called you Kara and Kara twice, not knowing which one it is. So please let us know how I should have pronounced your name and what your question is.
It's Kara.
Kara.
Yeah. So I have some confusion between what I've heard from like our retreat that we had, and then also what I hear from like our doctor, specifically our specific neurologist. So I asked her, because obviously there are some PDE families that don't follow a restricted diet and eat as much meat as they want and cheese, and I envy that because I want to be that, but I also am trying to follow guidance from our doctors, and so I'm confused as to why our doctors say that, like, if you eat over this amount of protein, which ours is 20 per day for our 7-year-old, for Maverick, and if you eat over that 20 per day, then you risk him having seizures. When other families from the retreat say, no, it can affect potentially how he does like in school or his how he learns and that kind of stuff. So it's not so much it's going to cause seizures, but it could affect how like down the line how he does with his like learning and stuff potentially. So
Yeah.
can it cause seizures if he eats too much protein, or is it a case by case? How does that work?
No, I don't think it would. So the amount of protein that a person needs really depends on their age and how active they are. So the goal is to give all the protein that Maverick needs for growing as a child and being active as a child, but not extra or not too much extra. And the too much extra is what tries to get broken down and creates that AASA. I have never heard of someone who ate so much protein that it impacted the B6 and they seized. We could try to do some calculation of how much protein that would be, but it would be more than I think a person could eat. So I guess the only other thing is if Maverick is taking the lowest B6 dose possible, like if he's taking 1 milligram one time a day, then maybe I would change my mind. But let's assume that he's taking the recommended dose. It would be impossible to eat that much lysine to cause seizures.
Good to know. Good to know.
It is possible that you are sick enough. Remember, as I said, that when we're sick and our muscles break down, we flood the system with lysine. And so when you're sick, and I know some of you have had breakthrough seizures or your kids have had breakthrough seizures, it's like all of these events at once. You're not eating very much because you're sick. You're breaking down the muscle, so you're flooding the system with the broken down lysine. And one thing that your brain does when it's sick is it's more likely to have a seizure. That is true for every person in the world. That is true for me and Christy in this room, who neither of us have PDE. So you just put all of those combinations together and you could have a breakthrough seizure. But if you're a child as well and they're taking B6, there's not enough lysine they could eat that would make them seize.
Okay, cool. Thank
Becky
you.
says, me next.
Yeah, so the thing we're struggling with Hazel is she's on like a downtrend for her lysine, even though her protein keeps going up and up and up. And is like, should I be like super worried about that? I mean, we just keep feeding her more and more and more, but she's a tank. She's
Yeah.
teething and it's all the things. And but every blood work now we're monthly, and we just kind of keep on this downtrend.
No, I mean, I just happen to know Becky's child really well since I've tried to hear about our clinic. But yeah, at this age, there are just times where your body is incorporating the food that you're eating into all of the things that are required for energy and growth. And so you just need a lot more lysine. And like, the reason that you see doctors and you see dietitians and we get those blood draws is we want to keep up with your kid. We don't want to give you too little. And so there are times in your life where your kid gets a lot of protein. They need it. They're growing. They're active. And then, I'm not as active as I wish I was. I don't need as much protein as I eat. Like it just changes over time. And again, one of the things we're excited about this work and so grateful for the Cure PD Foundation and all of you for funding this work is that we're saying things a lot in general, and we're really trying to move to some ways that we can give you some more specific recommendations. We are so excited to be part of this community. I know that Christy and I and other people in our lab, like our graduate student Nicole, we don't have PDE. We still feel really part of this group. We feel like part of the big family, and we really appreciate that. And we want to know if we're doing things that are important to you. So if you are on this call and you feel like, well, people said they're excited about what you're doing, but I'm not, reach out to us. We want to hear your viewpoint too. So you could get a hold of us through the Cure PDE group for sure, through Anna and Anastasia, or however you feel comfortable contacting us. You could contact us directly as well.
Nice wrap up, Curtis.
Thank you.
Yeah, thank you so much, everybody. Hope it was fun. I had a nice interview on the job side. Thank you, Curtis, for holding it down as always. All right, everybody. Thanks a lot. I'm going to stop the recording and we'll see you in a month. Which, by the way, if anybody has suggestions for other webinar speakers, if you have someone in your life who you think people would love to hear from, even if it's community related, for example, I don't know, you have a great like therapist that works with kids or some play activity that you think is fun, we could do a lot of different things. At one point I wanted to pitch like a PDE kids talent show. So anything's on the table for whatever you guys want to do. Okay, just reach out to us and let us know. So yeah. Let's see if I can stop it. Thanks a lot. Oh, nice. You have to stop the recording. All right, guys, I'm gonna kick everyone out.
Can we end it and rejoin? Would the link allow us? I'm not sure, because Anna texted me and said end it,
Yeah.
but I'm
do
not
you
sure
wanna-
if we're gonna be able to rejoin.
Do you want us to
Okay.
try?
Yeah, let's try.